Today, we're releasing the 1X World Model. Neo can now turn any prompt into autonomous action. With the latest update to the 1X World Model, Neo learns from internet-scale data and applies it to the real world. By visualizing future actions with a video model grounded in physics, Neo can generalize to new tasks it's never seen before. This opens a new path for robotics learning, one where robots learn by teaching themselves, using the data they generated on their own, and grow in AI capabilities alongside the rapidly improving video models.
Our world model is pre-trained on web-scale video data that captures human interaction, and then post-trained on robot data to ground that understanding in real-world physics and Neo's humanoid embodiment. This allows Neo to visualize future actions and use a built-in inverse dynamics model to turn those visualizations into movement. Today, we'll use the world model as Neo's cognitive core to execute autonomous action sequences several seconds long. How it works is you'll give Neo a prompt with voice or text. For this example, I'll use the world model desktop interface to illustrate how it comes together, and start with something simple, like having Neo pack this orange into the lunchbox. Once you prompt Neo, it'll take what it sees as input to generate a visualization of how to complete the request. As you can see on the screen below, Neo is visualizing how to perform this task using its world model. You can either have Neo automatically execute the generation or choose the best one to run from among several parallel generations. While Neo has never seen these objects before, there are still some examples of pick-and-place tasks in our dataset. So one might assume it's generalizing to a similar task to create this visualization. But this is not the case. With the world model, Neo can perform any task with any object, whether there is existing data or not. Not only has Neo never seen this toilet, but it has never performed a task anywhere near similar. Without any prior data on how to operate a toilet seat, the transfer of human knowledge becomes a lot more apparent. The world model is also really useful for handling unpredictable environments. Traditional AI models for robots are often overly sensitive to the surroundings, like changes in lighting or even random objects in the environment. Neo's world model, by contrast, applies human knowledge of how to navigate highly dynamic settings to handle even the most extreme changes in environment. Given a world model can generate just about anything you can imagine, there is no limit to what Neo can try and execute autonomously. We still have work to do to increase the length and success rate of each generated ability to make the world model more useful. But with the world model, Neo can create unlimited data of itself doing real-world tasks, creating a flywheel that enables Neo to teach itself anything, marking a true paradigm shift in AI and robotics.